Hi everyone, it's Judy. Welcome back to the OnTrack podcast. Today we're going to talk about the importance of learning. I think the person that said it best was Eric Bogatin at last year's AltiumLive. Take a look at this clip.
Everybody recognizes that you have to continually grow. It's kind of like in Alice in Wonderland. Alice is in the Red Forest, and the line goes something like, in this forest, you have to run faster and faster just to stay in the same place. And I think that encapsulates where the industry is today. That the most important skill you need, the technical skill and all that, but you need to be able to grow on your own, to learn on your own, take advantage of opportunities like what you have here at AltiumLive.
Now please join me in a conversation with Ben Jordan, where we explore a variety of ways that you can continue to learn and drive your career forward. Enjoy, I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, Ben, welcome back.
Thanks for having me.
I always love having you. So, today what I thought we'd talk about, some things you saw on the forum, some things we've been chatting about in the office. And at AltiumLive, we have this tagline that I coined, so I'm very proud of it. Learn, connect, get inspired. And so as we were chatting today in the office, I think what I'd like to talk with you about today is really the value of learning for today's engineer and PCB designer. I don't think that can be overstated. It's a huge thing, and the more complex products get, I think, the more it becomes critical. So, let's kick it off by, we started talking about something you saw in the forum that was heating up about CID.
Right.
So why don't you tell us about that a little bit?
Just in terms of timely topics, there was some discussion, I think it was about a month ago, because the IPC, who, if you're not familiar with the IPC in this industry, you really should be. That kind of the standards body. There's two big standards bodies that, really three, that have a lot to do with what we do in board level electronics design, specifically PCB design. And IPC is the main one, the Institute of Printed Circuits or whatever. I don't know what the meaning of it's changed over the years, but essentially it's the standards body. The other is JEDEC, and to a lesser extent IEEE, which is more the electronics engineering side of it and less involved with actual PCB manufacturing and design. Mm-hmm. And for a long time, a lot of us designers in the industry have found value in obtaining a certification called CID, Certified Interconnect Designer. I actually finally got around to doing it earlier this year. I've been meaning to do it for years. I've put other staff members at Altium through it. It's really valuable because it teaches you all the things you don't learn practically this. Where do I go with this? There's really two kinds of people who design circuit boards, and they're merging into really one and the same kind. And to me, I would refer to that person as a PCB design engineer. And whether they have an engineering degree or not, in the end, they eventually gather that level of expertise in this field, right? Whether it's through practical experience or through actual formal learning.
Right.
A lot of electrical engineers design boards. I'm an electrical engineer, actually a computer systems engineer, but I've always been into hardware. And for me personally, doing the CID was really valuable because it filled in a whole lot of knowledge gaps. So I learned about microcontrollers, about signaling and systems, about digital signal processing and all the math behind that stuff. That's the university education and or college education. But the practical, how to get a board made and get it made accurately, and how to document it, and what are all the issues to do with the materials and the material science. Like a lot of
oh my goodness,
a lot of the most absolute genius gurus I've met, who are the kinds of people who now teach CID classes, actually started out as materials scientists. So they know about, they know about physics and chemistry in ways I don't know. Yeah. And they've worked on the fabrication and really the cutting edge of, how to do really precise copper plating, for example. Right. And you don't learn all of that in an engineering degree for electronics.
You don't. And if you
touch
don't
on
know
that's it.
Yeah. And if you don't know it, it can really bite you. Like, what you don't know will hurt you. And I really like what, I've referred to this several times actually on the podcast, Kelly Dack. Early on, we did a podcast and he said, what is a designer? And then he talked about that a designer, part of the responsibility isn't to just know the tool and do the interconnects, but I'll also understand the needs of all the secondary stakeholders, which are your fabricators, your assemblers, your testers, and to look at the whole field and not just your piece. So he was sort of advocating to redefine that. And of course, Kelly's a CID teacher. No surprise.
So
and he's
really
a CID Plus.
Yep.
So he's really included that as part of what he thinks is essential knowledge.
It is. So, absolutely. Because at the end of the day, what does a designer do? What is the job of a designer? Well, you could say it's to design the circuit board. Right. But really, it's to convert an idea. Mm-hmm. It's to convert a plan, which is the engineering schematic. Really, that the schematic is a way for engineers to document their plan of how something's going to work. Right. And to take that and convert it into a set of information that a factory can use to produce an end product. That's hard. It's so hard. There's a lot involved with that. Oh my gosh. It used to be just more or less joining the dots. And then we got to into the mid-90s where we had computer motherboards and things where we were pushing clock speeds over 100 megahertz. Right. Signal integrity became an issue, so electrical engineers had to develop a deeper understanding of transmission lines as they apply to printed circuit boards. So there's engineering knowledge there and signals and systems, but then how do you manufacture something? And we've just kept pushing the envelope. Every generation of new chips that comes out. We push the envelope, and at the same time, again, from my perspective of manufacturing, we're pushing the envelope, but only having really nominal, iterative improvements to the manufacturing process. So, I always say we keep breaking these, what we say are unbreakable boundaries. We're saying, oh, that can't be done. A formula line can't be done. Well, we do that all the time now. Yeah. Right? But there was a time where we said that can't be done. But we'll get whatever. I think laser direct imaging was a huge step forward. Yeah. I think laser drilling was a big step forward. Amazing, yeah. So, but again, it's not like we came up with a whole new thing. It's an iterative thing on mechanical drilling, is now we do it with the laser so it can be smaller, more precise. But it's so, there hasn't been on the manufacturing side
We talk a lot now about printed electronics or doing additive. That would be a major leap forward if we could do that at production level. And I think we're getting there.
Yeah,
but
it's just a matter of time. There's a few cutting edge fabs that have developed processes and they're investing in the research to the experimentation to develop it. Now they'll often patent their processes.
Right.
But if they're sensible, they'll make the licensing fees low enough that most fabs could offer it as a service, and then it's accessible to everybody. That's sort of the win-win.
Yeah.
With and so, for a number of years at PCB West and DesignCon, I've seen samples of 1 mil track and space.
Yeah.
And that's like there was a time, think about it, in the industry maybe 20 years ago when 5 mil track and space.
Oh,
was
absolutely.
Cutting edge.
It was,
and it's like, look, we can do this. It'll cost you, but we can do it.
Right.
And then 5 mil track and space became the bog standard, as we'd say in Australia or New Zealand, bog standard. Now 3 mil track and space is bog standard, and before long, it's probably going to be 1. That's amazing.
It is, but that will involve breakthroughs with technologies such as a Veritech, which we've had on, where which is an additive process, because the subtractive process has inherent limitations. If you're etching away, you can only be so precise.
Yeah.
It's an etchant you dwell copper inside of a aqueous bath that has chemicals and etchants, and you can only be so precise. This isn't a laser.
Yeah.
It's like you said, a lot of moving pieces. So back to the CID piece that you saw on the forum, what was the hullabaloo that you saw going on with the conversation around CID?
So coming back to that, and the value of certification. So it's pretty well recognized that CID and CID Plus, which are certifications offered by IPC, are really useful because they close that gap about knowing how to present a board design and the results of your design to all the other stakeholders, testers, fabricators, assembly, and until you've actually studied it and done the certification, it's hard to really understand the value of it. So I recommend you do it. But the question came up, the IPC was asking or floating the idea that maybe we should make this like all of our other IPC certifications in other parts of the industry, that people can show that they're proficient at soldering or driving a particular kind of assembly process. That doesn't really apply at all to design engineers. It applies to other industry employees, and they have certifications, but they have to recertify every year or 2 years. So they have to do another test and update their certification. And that's okay if your employer is, and usually those things are employment driven. So your employer is paying for all their staff to go through this process, and they need to do that. It's in their interest to do that because it's a marketable thing that your staff are certified, right?
You bet.
But for CID, for designers, it caused an uproar because it's like the knowledge of how to document a design to send it to fab, or how to generate reproducible, and how to specify things, and how to make a data packet to send. It does change over time, but not enough to cause recertification to be warranted.
So what were people saying on the forum about it? I mean, what were they?
Well, the initial post I saw was from a chap who said, he provided the link to the article. Mike Buteau did an article in PC
UP Media's printed circuit design
and FabMech, and it raised this whole question too. And all the designers dogpiled onto this forum thread to say, we will not pay for doing this exam again. This is not fair. It's not warranted. It's just a money grab.
Well, let's talk about it. So, yeah, it's so Ben and I got on the phone with someone we know who is a CID and CID Plus instructor. And we said, is this true? What's going on here? And, one thing, if you do get CID or CID Plus, it's between $1,800 and $2,000. It's a 4-day class. It's intensive.
Yeah.
And
it's usually paid for by the person attending, not by their...
Yeah.
It's pretty...
Yeah.
If you can convince your boss to pay for you to do it, please do.
Yep.
It's absolutely will make you a better designer. So do it. But even if you have to pay yourself, it's still worth doing.
Yep.
Because it makes you a more marketable employee.
It sets you above,
better job prospects.
Right. It gives you that.
But it's expensive.
It is expensive, and it's done now through an organization called EPTAC that IPC has contracted to. So instead of managing it internally, they've contracted with an organization called EPTAC, who is a full training company, so they know how this is done. And anyways, Ben and I know a lot of people that teach those courses, and one thing I love that you've done here, Ben, is to require that our FAEs and AEs go get CID certified.
We've put quite a few through it now.
Which is, I think, great. We're putting our money where our mouth is, and I really like that.
This relates to, I think the IPC were looking at other industries too, and I've thought about this a lot. Back in the mid-90s, when I was an electronics technician and wanted better job prospects, I looked at what was open to technically minded people like me. Mm-hmm. So I took out a loan and paid out of my own pocket to do a Microsoft Certified Systems Engineer course and the set of exams required for that. And it was hard. And I passed all these, there were 5 exams and became an MCSE. And immediately I was able to get a better paying job by more than double what I was being paid as an electronics technician back in Australia. And it was a profound difference to me. It was well worth the investment. So there's that side of it as well. But I think the key difference was the CID training is teaching you the principles of good board design. And that's not related to a specific fab. It's not related to a specific assembly house. It's not related to a specific file format. It discusses some of those things, but it's more about design. Right. It's about design and stakeholders and making sure you technically provide the information necessary and that you know how to design a board to work right the first time. And whereas the MCSE for me was about a specific product. It was about knowing and supporting Microsoft Windows in a networked computing environment. And that stuff does change very rapidly because it's software. And but it made me think there's 2 things you need for being a good professional in the workplace. You need your theory, and we go to university and we do things like CID for the theory. And there's an element of practical knowledge there. I know what a resistor is. I know what a capacitor is. I know what ESR is. I know what ESL is. I can design circuits with a pen and paper drawing a schematic, right? But I also know how to use a multimeter. Yeah. Or an oscilloscope. Right. And so there's 2 sides to this coin. There's a theoretical knowledge and a practical knowledge. So you were mentioning that before.
Yeah. So since joining Altium and getting to work with universities, which is absolutely one of my favorite things to do, I've seen this happen over and over again. Within the last 6 months, we hired someone here. I think it was someone that maybe came to AltiumLive, but it was a student that had graduated with either a bachelor's or master's, as an EE, and did not get a job for a full year. And part of her problem, I know, it was crazy, but part of her problem was she hadn't done much practical, and that was a barrier to entry for her. And so I recently did a talk at Michigan Tech, and what I was trying to convey to them is what I'm seeing from my perspective is, as I get to go out and see competitions like the Hyperloop competition, those kids get snatched up before they graduate because they're getting this hands-on, they're moving from theory to practical. And so they have all the theory, but the theory is like your minimum viable price of entry. In these days, industry is requiring these kids to have hands-on, whether it's in the lab, robotics, it can't just be your capstone project.
Right.
It's got to be something more, and it's becoming more and more that way. And then I went to this CETA conference. I didn't tell you about this, Ben.
Yeah.
It was amazing. So I went to the CETA, which is the ECE Department Head Association. So 200 ECE department heads came from universities. This year, for the first year, they had a whole breakout session that were all people that ran labs on university. And I got to do a short little talk. It was like me and Keysight and Texas Instruments, and talk about what we're seeing, from our perspective. And the thing, all three of us who didn't really have a big sync up before had all come to the same conclusion. You cannot just do the theory, and that we're cheering on these lab professionals saying, build something, get these kids to build something, put it in a portfolio, because that will be the differentiator of you getting a job. So this idea that you just brought up from moving from theory to practical, these days, it's a non-negotiable. And at ECE, at the CETA, there was a guy who was a VP of Raytheon, and I borrowed his slide and I used it in my talk at Michigan Tech. And he said, well, here's your core technical things in the middle. And then he had 6 other things. This is the grid he looks for when he's hiring. And it was like communication skills, multidisciplinary, all these different things that when he's hiring, this is the grid he's looking through. So it's not just those core technical skills or the theory that you get from college. It's all these other things. And the term that kept coming up was systems-based thinking and multidisciplinary. And so, anyways, I could stand on that soapbox for a while.
I feel like there's a lot there. And I feel like, it just shows me there's still a lot we could be doing to help the industry and help people find their way into a career. Another topic that's come up in times past, maybe another whole topic for our podcast because we don't have time today, but it's how do we get new people to join this industry? There's more and more automation in our tools to do PCB layout and routing and so on, but it will always need people. And I keep hearing from, the Mike Credens of the world, things like that there's not enough new young people entering the industry, and what can we do to attract people to this as a career? Because it's a good career. I mean, you get paid well. There's demand. We see, on LinkedIn, I'm on LinkedIn pretty much weekly, and I see there's always companies wanting people who have experience in board layout and engineering. I'm encouraged to see more and more girls getting involved. I think that's cool. I've got 2 daughters and 1 son, and I actually think my oldest daughter is probably more inclined, like mentally, to get into engineering as a career. Hopefully she'll be a musician. which is what I should have done. But anyway.
Oh.
But I think what I'm getting here is, and this just confirms my own thinking, that there's really those two sides of the coin are needed. There's the theoretical and the practical. Now, you know, an idea that I've always loved the idea of offering a certification programs. IPC offers that with the CID, but again, it's general knowledge about design. It's not tool specific.
Right.
And I also see, from an insider's point of view, tons of people using CAD software and maybe not as being as efficient as they could be. And,
well, to that point, you or others, I've heard this kind of anecdotally floated around sort of inside the halls of Altium, is that 80% of our users use 20% of the tool. Why is that?
That's always been that way. It has, and all of my efforts as an applications engineer when I started at Altium, making all the videos I've made over time, all of that's driven by a desire to show people better ways of doing things in a practical sense in the tool. Again,
Right.
It's like, you know what a resistor is, you know how to lay out a board, but the multimeter you're using, the oscilloscope you're using has all these extra features that could actually make your life easier, but you haven't stopped to take a breath and read those sections of the manual necessarily to learn those things.
It
It's
reminds me of, like, I have an iPhone 10, like I have the top of the line iPhone 10, and I'm like this. Dun, 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 dun. I'm not one of these people.
We're all in that situation.
And so, but I can't tell you how many times my 20-something-year-old girls come up and like, give me that, boom, boom, and they do something. I'm like, that was amazing.
Just with a gesture.
Yes, with a gesture or something. And I'm like, oh my gosh, that one thing could have saved me so much time on that dumb phone. So I have this very powerful iPhone in my pocket, and I'm using a fraction of what is, but I love when my kids come show me a shortcut or something. It's life-changing. So I feel like it's kind of the same in our tool, right? You know, there's keyboard shortcuts, or there's features or something that, I don't know, maybe it's just a hazard of technology in general.
Yeah, it is true. And I think in terms of actual design tools in CAD, like Altium Designer, for example, there's a lot of different ways you can get the same job done. And some are very simple and easy, but less efficient. Others very powerful, but require a lot more forethought and planning. And you know, library management is a great example of that. You can just use a discrete schematic library for generic symbols and specific components, and you can couple that with a PCB library for your footprints, and you can have a library full of just IP3 7351 footprints, or you can name them based on the manufacturer diagrams and use them specifically one-to-one with a symbol. And it works, but it's error. You know, you can end up with a mess, and it can be error prone, and it's hard to keep track of versions and what changed. And so, just to get started, to be productive immediately on day one, you do things that way. But hopefully, over time, you learn new features of the tool, and you get more efficient. And in fact, in this industry, you really need to. You need to constantly be learning new things and getting more and more, squeezing more juice out of the tools.
It's a time-saving thing, right? I mean, isn't that one of the key benefits, is really to save time?
Yeah, that's right.
Yeah.
Save time, reuse things. I mean, and I think Eric Bogatin said something along those lines.
Yeah,
in
he
one
did
of the
it.
other videos I saw.
Yeah.
He was quoting about one of the characters in
Alice in Wonderland.
Alice in Wonderland about running faster and faster just to stay in the same place.
Yes.
Well, you kind of do need to do that. So I'm always trying to encourage users to learn more about the tool, And that comes back to that whole certification topic. Maybe there should be a product-centric certification. Just an idea, throwing it out there.
I would love to hear from you guys,
Yeah.
our listeners and watchers, what your thoughts are on it, certification with tool, whatever tool you use. How would you value that? You know, if you could get a formal certification, you know, some kind of badge of honor that said you were certified to some level of proficiency or
Yeah.
expertise in a tool, would that help your career? Would that help you?
I think it would help employers find people who they know can hit the ground running.
Yeah, it kind of sets you apart. Oh, which ties back to the experience that I had at a CETA, is all the experts were saying, particularly the VP from Raytheon, he was saying, when we hire somebody, the reason why we want all these skill set is because the ramp to productivity is short.
Yeah.
They don't want to take 12, 18 months to
Right.
take a new hire to get them to be productive for the team. They want that ramp to productivity to be as brief as possible. So I think, to your point, you know, not only CID, but having tool training
Yeah.
is kind of a marker.
Yeah.
I mean, that's what I think philosophically, but I would love to hear from you guys. And
Yeah, absolutely.
I'm sure Ben would too. So,
I
come
think
on the
it c-
forums or comment here below. I'd really like to hear what your thoughts on it, if you think that would be beneficial.
Yeah, I mean, even larger engineering organizations. So many people would be familiar with IEEE, and there are, even in that side of the industry, your first main task as a career engineer, usually, again, it's not necessary. You don't have to have an engineering degree to be an engineer. You do have to learn, and you do constantly have to learn.
We've had Dan Beaker on here, which he actually, I don't know if you know this about Dan, he never got his EE.
No,
he
I never.
learned it.
I would never know that.
Never know that, because he learned it from pros heavily over time, and NXP actually recognized his knowledge and gave him the title engineer.
Right.
And so, but he demonstrated that knowledge over a career and earned that very practically.
That's right. But so even industry orgs like IEEE have this recognition path. They call it a certified professional engineer, and there's the similar things in mechanical and civil engineering and so on. And to maintain that status, you need to show that you're continually learning. So,
which is like Eric
a lot of people-
Bogatin's thing,
a lot of
right? It's
people
the
don't do it.
continuing ed thing, right?
The real test is your job, right? It's your employment and the fact that you're valued in the industry, and people want to hire you as an expert or as a consultant, or like Dan, you've got tenure and rank at a company like NXP that recognizes and values you. So again, you don't necessarily have to do any kind of exams to show what you know. Your real exam is life.
Right.
Right.
School of Hard Knocks, baby.
But having these additional things, I think having CID, for me personally, if I was hiring someone in an engineering role, I would look for CID for sure, and I would look for knowledge of the software, because I want to make sure they're efficient when they come on board. That again, it comes down to that ramp up, and maybe our friend who was looking for a job for a year.
Yes.
From UCSD, which is a great school, theoretically, they graduate some really talented people.
They do. But they've also been getting feedback from the industry at large, at least here in San Diego, saying you're too theory heavy. And so Qualcomm's working with them to open more prototype spaces and prototype labs, and I've worked with some of those. So the industry is actually giving some feedback.
That's great.
In those regards, and I think it
Yeah.
is. I think it's a good.
Yeah, and that's why some universities offer internship a sandwich program, we call it in Australia, where you do 6 months study and then 6 months work experience.
I think those are the best programs.
Fantastic.
They do that in Canada too, and I'm like, that's full-time hands-on, right? I think that's a very valuable model. I wish we did that more in the U.S. Actually, we don't really adopt it.
I think one thing that's clear in all of this is that an engineer's life is dedicated to learning stuff. You can't.
No, and it's continual. You can't stop. No,
Like I started as an electronics technician, and I went back to university after having a family and kids, and it was hard. Moved countries 3 times. Did the Bachelor of Engineering in Computer Systems, but I'm into circuit board design too, so I've done CID, and I just think I'm not saying all of that to toot my horn. I think there's a lot of people out there who've done way more difficult things and a lot more than I've gotten to. All I'm saying is, I guess you get this bug as a technical person in the board level design space. I think people who are drawn towards it are naturally, they're problem solvers, they're puzzle solvers.
Yes, and I think they're naturally
constantly curious.
Curious, that's the word I was going to say. I think curiosity, and by the way, even though I'm not a board designer, curiosity absolutely is the driving force of my life, and I will never stop until I cannot get out of a bed. Yes, it's what brought me here. Is I'm so curious, and I love learning, and I love seeing. And by the way, because of my role here at Altium, because I've had the opportunity to interview and talk to so many people that I have immense respect for, the common thread, they all say that. That learning, self-motivated, driven learning is I've heard it from Susie Webb, Eric Bogatin, Rick Hartley. I've heard it from all of them, and everyone, like I said, that I have a lot of respect for. They're very high performing people. They've all said that ongoing learning, whether you're
What do you think the motivation is for that? Why do us in this industry, why do we, people like you and me, want to keep learning stuff and getting better at what we do? Like,
I can only talk for myself, but if I had to do the same thing every single day, and there was nothing new or fresh, and it was repetitive, I would be in a fetal position on the floor. I would hate it. I would hate it. It's kind of what gives me joy. It's what gives me joy.
Yeah.
And I've said many times that over the span of my career, it's exciting to go inside of SpaceX or Lockheed Martin or go to JPL and see the Mars rover. This is exciting.
It is
stuff.
It's cool knowing you're part of something, even in an indirect
even if it's
way.
A little circuit board inside that really Mars rover. Years and years ago, I sold to Magellan Systems when GPS was a very young technology, and the U.S. government had just released the constellation of satellites to the public, which is what allowed for GPS to happen.
Yep.
And being part of that, and again, I was helping Magellan build circuit boards and working with their manufacturing engineer and a ton of work. But I was seeing things before it hit the market. I was seeing these big clunky screens they're putting inside cars. Now they're all on our phones, right? But there used to be a big gooseneck with a giant screen on it and CDs in the trunk and really clunky. But to see, here's a Japanese consortium flying into Magellan to have this rollout,
wow.
and see it really before the public saw it.
Yeah.
So exciting to see, here's where the world is going.
Yeah.
And I just find that, that's my answer. What about you?
Yeah. It's a mix. I think from a very young age, I was curious about how things worked, like most engineers. I pull things apart. I remember pulling apart handheld transistor radios when I was like 6 or 7, and looking at all the funny little objects inside, resistors and caps. Now I know what they are, and transistors, and thinking, what are these? And looking at the circuit board and this intricate pattern, and pretending they were race car tracks, and tracing my fingers around the tracks on the back of the board. I remember doing that as like a 6 or 7 year old, and then my big brother was a technician and built his own guitar amplifiers, and he was kind of my hero. So he got me into electronics from about 8. But I also took pleasure in knowing things that were kind of esoteric. So there's a little bit of pride, to be honest. I do have that, a little bit of pride knowing that I know how some things work that are kind of strange and difficult. But that's only a fraction of it.
I feel like that's a healthy pride, though. I mean,
well, as long as I'm aware of it and I don't get, it's not good to be conceited, right? But I think most people who design PCBs take pleasure in that, and it is an art form. I think one of the nice things about PCBs is you could say they're all the same. They're just layers of copper and tracing things and making sure you have good grounding and signal integrity. And yeah, you could see it that way, but if you truly see it that way, you probably won't last in the industry. You'll find some other job. The thing about PCB design is every single new PCB design is new. Like you ask a painter,
right,
someone who paints beautiful art, do you ever get bored of painting? No, they don't. Not any of the ones I know. Why? Every painting's a new painting. You're not painting the same thing over and over. Right. And this is where it comes back to what you said about
it keeps me
monotony.
Yes.
There's no monotony.
It's the opposite of monotony. I actually feel, the people that I've known, I feel it here at Altium, like we're a weird bunch. Like, not weird as in peculiar, but we're unique. That we have this drive and this thing that we're really inspired by. And well, we're running out of time, so to kind of wrap up here, in the next week or two, I wanted to put in a little plug here for AltiumLive, because that is one place where you can certainly get some of that learning. And I was thinking about things that you said earlier and about the 80-20 rule, right?
Yeah.
And so I just spoke on the phone yesterday to Robert Faranik, and he's going to be one of our keynotes, so I hope you'll come join us and see Robert. So Robert, again, being one of these like crazy curious people, for weeks he hit me up and I threw him names of people who ran large design teams, all military, electric vehicles, like a whole bunch. And he's been doing this deep research. And his whole point of doing that research is kind of, why do people only use that 20%? And if I could tell them what bigger design teams, how they leveraged some of that knowledge to speed up their design, what would that look like? And so his curiosity drove him, and then he's going to be presenting his conclusions. And
that's really important.
And what he learned. And so
I think you really need to be at AltiumLive, and you're not going to get a better experience for learning new tricks.
No.
You could spend a few $1,000s, honestly, and go to one of our trainings, and that's great if you can afford it, or if your company is willing to send you. Absolutely attend a training with an instructor.
Right.
And you can get into the weeds there. But AltiumLive, you're not going to find any place where you get the level of technical expertise in one place, and people doing, and it's not just from us. That's what I love about it. It's from actual other Altium users.
There's people that teach there that use other tools. There's a lot of them, because sort of as this puts kind of a bow on the package of on the package of our conversation here, is that we've been talking about, so on day one of AltiumLive is University Day. So on that day you can get the tool training, right? So you can learn how to be a better master of your tool. If that's not of interest and you're already a master, then we're going to have a full day class by Rick Hartley about EMI and noise control.
Fantastic.
And then we're going to have another full day class by Gary Ferrari, and it's about manufacturing. It's like CID in a day. It's designed for everything. And this guy's been in the industry for 40 years. He's brilliant.
Yeah, he is.
And he talks like a New Yorker, and he's entertaining. I love Gary Ferrari. He'll be great.
Yeah.
So that, and then the normal 2-day main summit, that's just all about PCB design. And it's open to anybody, not just Altium designer users. And so wrapping up our conversation, you get that, the tool side and the it's sort of like you get the CID and the tool.
Yeah.
That type of training.
It's the theory and the practical.
It's the theory and the practical.
Or practical and practical, really.
Really. So, and that's been designed by our team on purpose that way. So we do hope you'll join us, and keep your eye out for the podcast with Robert Feranek. So I'm really proud to be on this team and to be able to offer that level of training. And
yeah, it's great.
In line with,
and
everything we've talked about
also,
today.
Keep your eye on our YouTube channels, because we're trying to consistently update the tips. There's always going to be, with a
whiteboard series
software like what Altium produces, there's always going to be more information about how you can do something better. And
some general topics too, just like printed electronics. Some of it's tool based and some of it's just practical.
Yep. You've just got to take the time. Remember, you're in this to learn as much as work. And 10 minutes of looking at a new tip on the front end of your day could mean hours and hours in that week of gained productivity. It's like, are you using the tools the way they're designed and getting the most out of them? There's always something more to learn.
Trust me, you don't want to be like me and my iPhone. You want to be better than that.
I get it. I mean, you've
I
got
mean,
to start somewhere, right?
But I am learning over time. You know what I'm saying? That's I'm being challenged. So, well, this has been a great and a rich conversation. I hope you've enjoyed it as well. And pre-registration for AltiumLive is now open. The reason why you would want to pre-register is because it automatically qualifies you for an early bird discount. And, we don't want to sound like salespeople here, but it is a really wonderful experience. And the San Diego event is October 9th through 11th. If you are in Europe, we will be in Frankfurt, October 21st through 23rd. So we hope you'll join us as we bring the community together, and you can rub shoulders with other curious minds like yourself. So thanks for joining us today, Ben. Thank you for joining.
Thanks for having me. It's
a
pleasure.
It's always my pleasure to have you. So we'll see you next time. Hope you enjoyed today. See you on the next podcast with Robert Feranek. Until then, remember to always stay on track.